Hello guys, in this video you will be learning about luminescence and different types of it. Before understanding what this is, let's watch a video first.
To start, let's define triboluminescence. Triboluminescence is a type of luminescence in which certain materials undergo mechanical processes, including rubbing, grinding, or crushing, which results in the production of light. Triboluminescence is a special kind of luminescence that is entirely mechanical in nature, unlike other forms of luminescence that need chemical or electrical processes. Let's speak about applications now. Triboluminescence is a breakthrough in the field of materials research, not merely a fun party trick. Scientists can learn a great deal about the structure and behavior of triboluminescent materials under stress. Imagine being able to tell whether a building is stressed or has mechanical damage just by looking at the light it generates. That is what triboluminescence is capable of. Fluorescence is a type of luminescence where certain materials absorb light at one wavelength and then promptly release light at a different wavelength. Let's continue exploring the intriguing world of fluorescence. Beyond its alluring glow, fluorescence is caused by complex processes that include electrons absorbing photons and then emitting. Longer wavelength light as a result, there are several uses for this phenomena in many different industries. Fluorescent probes and dyes are transforming medical diagnosis and medication discovery in biomedical imaging by enabling researchers to see cellular architecture and follow biological processes with remarkable accuracy. Furthermore, fluorescence is essential for environmental monitoring since it helps identify contaminants and evaluate the health of ecosystems. Fluorescent markers are a useful tool in forensic science, helping to improve criminal investigations by detecting body fluids and evaluating trace evidence. Unlike fluorescence, where light is emitted almost immediately after absorption, phosphorescence presents a distinct phenomenon. In contrast to fluorescence, phosphorescence is a distinct phenomena in the field of luminescence. Phosphorescence behaves differently from fluorescence, which emits light nearly instantly after photons are absorbed. Similar to that, this process starts when some molecules absorb photons, which causes their electrons to move from one energy level to another. However, in phosphorescent materials, the excited electrons go through a spin-forbidden transition rather of instantly reverting to their ground state and releasing energy as light as observed in fluorescence. A longer-lived excited state as a result of this transition causes light to emit later after the light source is removed. The length of this emission can vary based on the particular characteristics of the phosphorescent substance from milliseconds to hours. There are numerous examples of phosphorescence in both man-made and natural environments. Phosphorescent materials provide long-lasting brightness for visibility in low light. They are utilized in glow-in-the-dark items and can be found in nature. They are essential in several areas such as medical imaging, OLEDs, lighting, and displays due to their distinct optical characteristics. They are also useful for scientific researches. The next subtopic we are going to study is called bioluminescence. The glowing phenomenon you're looking at is called bioluminescence. Around the world, bioluminescence is a remarkable natural phenomena that occurs in a variety of terrestrial and marine habitats. It happens when light-emitting molecules called luciferin and an enzyme called luciferase react chemically to make and emit light in living things. In marine environments, bioluminescence is particularly common and serves various purposes. Many deep-sea organisms, such as anglerfish, use bioluminescence to attract prey or potential mates in the dark depths, where sunlight does not penetrate. Some species of jellyfish and cum jellies use bioluminescence for defense, creating bright flashes of light to startle predators or distract them while they escape. Bioluminescence isn't limited to marine environments. Fireflies, for example, are well-known terrestrial bioluminescent organisms. The flashing patterns of light produced by fireflies are used primarily for mating purposes, with males and females using specific flashing sequences to identify and attract each other. Overall, bioluminescence is an amazing adaptation that is present in many different environments and has a variety of uses, including communication camouflage, attracting prey, deterring predators, and finding mates. Let's explore the fascinating realm of chemiluminescence, a fascinating phenomena in which some materials quickly release light after absorbing energy from a chemical process, in contrast to fluorescence, which is the result of light photons being absorbed. Chemiluminescence gets its brightness from the energy produced when a chemical reaction occurs. Text: why and how does it emit light? Usually, the wavelength of light emitted during a chemical reaction is longer than the wavelength of energy absorbed, resulting in a visible glow. When certain molecules experience a chemical reaction, they shift to higher energy levels before eventually returning to their stable form. Now let's explore the fascinating phenomena of thermoluminescence, which is the emission of light by some materials upon heating. Thermoluminescence is induced by heat energy in contrast to fluorescence and chemiluminescence, which are caused by chemical or photon absorption processes. Certain materials' electrons become trapped in tiny holes in the material's structure when they are subjected to radiation, such as sunlight or X-rays. Over time, these imprisoned electrons slowly absorb energy from their surroundings.